So hi guys, in the last video we learned about the product rule, which we used two different terms that contained x and multiplied them together, and then found the derivative using a specific equation. In this video we're going to be doing something that's pretty similar. It's known as the quotient rule. Now, like a product is when two things are multiplied together, quotient is two things that are divided by each other. So that would be something looking like this, u over v. There's a division sign in between. So it shows that it's quotient. That's why it's a quotient rule. It's meant for these kind of expressions. Now, it's also meant for things like 1 over x. 1 over x could be represented, however, you might notice, as x to the power of -1, and then we could just use the power rule to write it out and simplify it to this. But what if you had things like x squared plus 3x plus 3 divided by 4x to the power of 4? Well, then things would be a little bit more complicated. And I don't think using a product rule, chain rule, power rule as well, all of those in one is very helpful. It would be much better suited to just use one rule. Oops. All right. So the quotient rule is known as, so let's say you have u over v, right? We're going to use this structure to write the quotient rule. It's essentially v times the derivative of u, which is known as u prime, minus v's derivative times u divided by v squared. So in this case of 1 over x, if you're using dy over dx of 1 over x, that would be represented. So u would be, we'd first write down our u and v values and then derivatives of each. So u is 1, v is x. Derivative of u is just 0. Derivative of v is 1. I'll just write u and v prime. Now you can just substitute into the equation. So v times u prime, 1 times 0. 1 times 0, we'll just write that in brackets, minus, and then v prime times u. V prime is 1, and u is 1 as well. So it'll be 1 times 1, divided by, and then v squared is x squared. This would look like, so 1 times 0 is just 0. So 0 minus 1 is -1 over x squared, which is the same as this. Okay, so now let's do it with a more complicated problem, because the ones that we've been doing, the one we just did rather, is pretty easy. I'm sure it's quite manageable. So let me just erase everything here. Okay, so let's say we had the expression y equals 3x squared plus 4x divided by 2x cubed, and we have to find dy over dx. Well, first we'd write down the formula. That's the best thing to do. So it's v times u prime minus v prime times u divided by v squared. The way I think about it is that the denominator is first not differentiated. So you take the thing that's in the v squared and drag it to the top without changing it. You just square root it. However, the numerator is the first thing that gets squared. So like the numerator is the top part, so it's the first thing to get differentiated. Think of it that way. All right, so now we can evaluate this by first finding out the values of v, u prime, and v prime. So first, our u. Well, we know that the quotient rule is written given that u over v is the expression. So if we have that means u is 3x squared plus 4x. And we can therefore deduce that u prime, using the power rule, is 6x plus 4. You can check that yourself. I'm just doing it pretty quickly. Then we have v. V is the denominator, so that's 2x cubed. That means v prime is 6x squared. Okay, now we're ready to actually evaluate this. So let's put in the equation. So we have 2x cubed times 6x plus 4. Notice I multiplied v by u prime. That's subtracted from v prime, which is 6x squared, times u, 3x squared plus 4x, which is divided by 2x cubed squared. Okay, I'm going to scroll down to make more space. Let's simplify. So In the next problem we'll do, I won't simplify it, but here I'll just simplify to show how the algebra works itself out. You have 12x to the power of 4 plus 8x cubed minus 18x to the power of 4 plus 24x to the power of 3 divided by 4x to the power of 6. Indices are quite helpful when you're working with these kind of things. Then let's collect like terms in the numerators. 12x to the power of 4 minus 18x to the power of 4 is negative 6x to the power of 4. And 8x to the power of 3 plus 24x to the power of 3 is... Oops, notice I actually just made a mistake. And if you noticed it, yes, it's this plus sign. It's meant to be a minus sign. Because over here, you're subtracting all the terms in here. So even though we have a plus sign over here, we still have a minus sign, and a plus and a minus sign make a minus sign. So it's actually a minus sign there. And so then we have 8x to the power of 3 minus 24x cubed, which gives us negative 16x cubed, which is divided by 4x to the power of 6. Okay, now we can simplify further. So we can put the subtraction sign at the side, and write this as 6x to the power of 4 plus 16x cubed. It's a bit like putting this in brackets, and then here this would all turn negative because it's one expression. But we can remove the brackets because we know it's meant to be like this. Becomes 4x to the power of 6. Simplifies to negative. So we can see that all these are divisible by 2, all these terms. So that would become negative 3x to the power of 4 plus 8x cubed divided by 2x to the power of 6. And we can also factor out some x's. Let me draw it over here. So that would be negative. So we can see that the x cubed can actually be taken out if we just divide everything by x cubed. So negative 3x plus 8 divided by 2x cubed is our answer. That is the derivative of this expression that we have up here. This is the answer. Okay, let's do one more problem and then we'll wrap up this video. Okay, so here's another problem here that requires the quotient rule because there's division in it. I'm only gonna use the formula and input the values, but then after that, I'm not gonna really do the simplification because sometimes it's not even necessary, and I think it's just algebra at that point. It's not really anything that's gonna help you because it's easy to do anyway. So it might just be a waste of time to look at. So first we've got to identify our u and v values. And before we even do that, let's first write down the equation. So if we have u over v, then dy over dx is u prime times v minus u times v prime over v squared. So our u is clearly the numerator and the v is denominator. So the u is root x plus 2x. But helpful to write it as a power. So it's x to the power of half plus 2x. That makes it really easy to find the derivative of. Then v is 7x minus 4x squared, which means that u prime is half x to the power of negative half, which is, plus 2, that's first 2, which is 1 over 2 to the root x plus 2. And then v prime is 7 minus 8x. Okay, so now we have all our terms that we need. I would actually write this as a fraction to the same denominator. So I'd make this 1 plus 4 root x divided by 2 root x, just to make it a little bit easier. So now we've got all our values. Let's substitute them in. So first we have to do a u prime times v. So that's 1 plus 4 root x divided by 2 root x. And that's going to be multiplied by v, which is 7x minus 4x squared, which is subtracted from v prime, which is 7 minus 8x, times u, which is root x plus 2x, which is all divided by 7x minus 4x squared. Now, we can easily evaluate this and then simplify it down. Just make sure you check your work at all times. And also remember there's a minus sign here, so it has to get carried down everywhere. Except for over here, where the two minuses would make a plus sign. So that would just be the plus. So that would be added, if you know what I mean. So two minuses make a plus and a minus make a minus, and two pluses make a plus, obviously. Just remember that the minus sign exists. It's not a plus sign there. I've made that mistake before. So this is essentially the answer without all the simplifying done. I'll let you do the simplifying on your own. And other than that, I think that's it. That's the quotient rule for you. I'll put some worksheets in the description below so we can get some practice in. But yeah. Oh, and before I forget, this is meant to be squared, this part over here. Like, there's these little things that I keep forgetting, and just be careful that you don't forget them too. But yeah, that's it. Thanks for watching, and see you in the next video.